Hi, I'm Dan Elliott, and in the last video we learned how to use SplineMesh components, and in this one we're going to continue with that and learn how to use SplineMesh components to create repeating geometry and create a tool which allows us to build roads and pathways. So I'm going to start from where we left off in a previous video with our spline actor blueprint, where we had a repeating rock that was placed along a spline. And what I'm going to do is, where we have add static mesh component, instead of adding a static mesh component, I want to create a spline mesh component. And here's a function, add spline mesh component. So we're going to replace the add static mesh component with the spline mesh component. And we're going to connect the set static mesh function to the spline component instead of the static mesh component, which we're just going to delete. So like in the last video, we want to be able to set the start and end positions of these spline mesh components as they're created. So we can start typing set start, and we'll need to uncheck context sensitive in this case. And we can see under spline mesh we have set start and end. And we're going to connect up this execution pin. And the target of this set start and end function is going to be the spline mesh component that we've created before. So now we want a way to set the start and end positions and tangents as they're created along the spline. These nodes return a world location at a distance along spline. So we're going to use the same functions to be able to do that. The difference here is that we're not going to be using a make transform node, as the set start and end node receives a position vector directly. So we can delete the make transform node and also this combine rotators node, and we're going to connect this position directly to the start position. And we can see that the start tangent doesn't take a rotation value. So instead of a get world rotation at distance along spline, what we want to do is type get world direction at distance along spline. And if we look at the if we hover over this node, we can see that it says, given a distance along the length of this spline, return a unit direction vector of the spline tangent there. And that's important that it says unit direction, because we'll be coming back to that later. So what we do is we connect our target to the spline reference, and the distance that we want to sample will be the same as our spacing distance multiplied by the loop index, and we'll connect that to the start tangent. Now we need an end tangent, and what we will be doing is duplicating these two nodes, and what we want to be doing is connecting the target to these two nodes, so we're sampling the same spline, and the distance along that spline will be the same as the current distance plus the spacing, which will give us that distance plus the next one along. So we want to choose float plus float, and we'll add the current distance to the spacing variable, and we'll connect that distance to these two nodes. And now these will serve as the endpoints of our spline mesh components. And what I want to do is I want to choose a different static mesh. I'm going to come to my content browser, and in my content browser I've imported a plane, which if I drag it in to the scene, we can see that it's just a simple plane, which if we look in wireframe has been divided a few times. Now if we go back to our spline actor blueprint and set that static mesh to be plain and compile, and we have an error, and we can see that error, if we click on this, it says that this blueprint is not a primitive component, therefore target must have a connection. So we need to set the target on this set material node, and that target will be the SplineMesh component. Because we deleted the add static mesh component, that connection had been lost. So now if we compile, we see that it's working. We can come over to our Spline active blueprint, and we can see that we're getting the double transform problem again. So what we'll do is we'll come back into the blueprint graph and we'll choose manual attachment and compile that. So now if we look at our spline blueprint and drag this out, we can see we're getting this repeating pattern of geometry. And we're seeing that our geometry is bunched up right at the moment, whereas the plane that I imported was a square. So the reason for that is because the spacing isn't set to be the length of that square, which I know to be 200 units. So now we can see that this plane is being repeated along the length of the spline with equal spacing between them. And then we can also see the effect of the spline mesh being deformed at the last point, where the end point is too short and it's deforming that last plane. So let's see what happens when I go and add a new point to the spline. I'm going to hold Alt and drag out, so we now have a point in the middle. If I drag this up, we can see that the planes are being deformed along the length of the spline, but we can also see that it's not completely smooth. And the reason for that at the moment is that the tangents generated from this function are unit direction vectors, which means that they've been scaled to have a length of 1, whereas we want the tangents to be unscaled. And at the moment this doesn't seem to be a way to get unscaled tangents directly using the distance along spline functions. So the only way we can get around that at the moment is we can multiply these tangents manually. So I'm going to create a vector times float function, and I'm going to get our tangent here, and I'm going to duplicate this as well because we want to do it to 2 of them. I'm going to get this tangent here, and I'm going to create a new variable called tangent scale, make that a float, and get a reference to this in our graph. If I connect that up to these 2 multiplication nodes and then plug them into their respective tangent input pins and compile, well, actually what we'll see is that this tangent scale is at 0, so we'll be scaling the tangents to 0, which is what's causing these small gaps here. But if we set a default value of 1, compile, that gets rid of the gaps. Now if we make that variable editable in the details panel, then we can start to raise this tangent scale, and now that will start to have an effect further out from these points, and we'll get a smooth transition. So if I move these points to the side, we can see that we're getting a smooth transition. If this tangent scale was as it was, we'd see these sharp transitions between these spline meshes. But now, if we bring that back up, we get a nice smooth transition. And the good thing about this setup is the UVs of the mesh aren't deformed, they're not stretched. If we were to use the other method of grabbing the start and end points of the spline mesh by using the spline points, then what we would get would be a spline mesh stretched from here to here, and then another one from here to here, which isn't what we want. We want nice repeating geometry that doesn't stretch, so that we can put a texture on here and it would look nice. And don't be concerned by these lines, because if we do a quick build of the lighting, then that should get rid of them, and we should see very soon. There we go, that's all gone. We will get some texture seams if your textures aren't seamless, but hopefully if you go and be selective with your textures and make sure that they're seamless, then we can make sure that they're nice and repeatable and we won't see any seams. One thing that's worth mentioning is that any collision that the original static mesh has also gets instanced and deformed along with the spline mesh. So if we come along to our actor blueprint and we search for set collision enabled, and if we just plug this in between these two nodes so that this gets executed and set the target to be the spline mesh component, if we set the collision to collision enabled, compile, and then we come to show player collision, we can see that that plane collision is also deformed and instanced along the spline. Now you might want to make sure that the collision mesh has enough vertices in it to be able to be deformed as smoothly as the original mesh. Otherwise your character is going to collide differently to what's being rendered on the screen. So let's go back to lit, and I'm going to switch the mesh over to another mesh that I created, which is similar to the plane, but it has geometry extruded up at the sides. So it just goes to show how you can create nice smooth geometry with collisions, with boundaries at the side, and have it update dynamically. I think this could be a pretty handy tool in a lot of games, so I hope you all have a lot of fun with it. And if you've got any questions, feel free to comment, and if you've been happy with what I've shown you, then please subscribe, and I hope to do a lot of tutorials in the future. Thanks for watching.